Compute the derivative of the following function. G of x is equal to the natural log of the quantity 2x plus 5 divided by the quantity 3x minus 2 squared. Now, if we wanted to take the derivative using some of our derivative rules, this would be a composite function because we have this natural log function as our outer function, and then the inner function is a pretty nasty quotient. So that would require both chain rule as well as quotient rule, and while we could do it that way, it'd be pretty complicated and quite messy. So instead, I'm proposing that we use some of our previous knowledge about logarithms, specifically the properties of logarithms, and let's work to expand this logarithm before we jump into the derivative. So to do that, we're going to utilize the properties of logarithms, starting with the first property, which is when you have a quotient. Here's our quotient in the argument of the logarithm. We know that quotients are going to expand into subtraction. So this logarithm will expand into the natural log of 2x plus 5 minus the natural log of the denominator, which is 3x minus 2 squared. So that's called the quotient rule for logarithms. Then we want to look at these logarithms that we have, and there's two logarithms now, and want to see if we can use the properties of logs anymore to continue expanding. So this first logarithm, the logarithm, a natural log of 2x plus 5, we can't touch that any longer. The argument is just 2x plus 5. We only can basically expand logarithms that have multiplication or division in the argument, or logarithms that have an argument raised to a power. So because of this addition here in the 2x plus 5, that's telling us we cannot use any more properties of logs. So the first logarithm is done. But this second logarithm, we see that we have this argument raised to the second power. So the power rule for logarithms allows us to bring the 2 out in front and rewrite this as multiplication. So now my function, g of x, will equal the natural log of 2x plus 5 minus 2 times the natural log of 3x minus 2. And once again, if we look at the second logarithm, we look at the argument, we see the argument is 3x minus 2, and because of this subtraction, we know that we are done and we cannot use any additional properties of logs. So now what we've essentially done is we've changed our function into a function that has two terms. So the first term is the natural log of 2x plus 5, and the second term is the 2 times natural log of 3x minus 2. So now we can go ahead and take the derivative of each of these two terms separately. And we just have to recognize that each of these terms are composite functions. So we're going to be using the chain rule. So this first logarithm, the natural log of 2x plus 5, if we think of it as a composite function, my outer function is the natural log of x, but I'm going to write that as the natural log of something. And then my inner function will be 2x plus 5. My second function here, once again, which is also a composite function, my outer function is 2 times the natural log of x. I'll write that as the natural log of something. And my inner function will be 3x minus 2. So just writing my outer and inner functions so that I can see the chain rule in action. So now we'll compute our derivative. So the derivative of the natural log of something will be 1 over something. And then we're always going to insert the original g function, which is the original inner function. So that's 1 over 2x plus 5. And then we do our chain rule and we chain on the derivative of the g function, and the derivative of 2x plus 5 is just 2. Minus, we have a constant multiple of 2, so that'll just be in front, multiplied, by the derivative of natural log of something, which again is 1 over something. We'll input the original inner function, which is 3x minus 2, and then multiply that, this is the chain rule, multiplying it by the derivative of the g function, and the derivative of 3x minus 2 will just be 3. So by using those properties of logarithms, we basically avoided doing a really nasty chain rule that would have required the quotient rule. So we'll end up with 2 divided by 2x plus 5 minus 6 divided by 3x minus 2. And we're done. So again, be on the lookout for functions like this that involve logarithms. And if you can take the logarithm and first apply the properties of logarithms, that will help make the calculus steps much easier when it comes time to compute your derivative.